Okay, Algebra 1 fans, our topic for today, this is Notes, Section 9-6, the quadratic formula and the discriminant. Before we begin, let me tell you your joke of the day. Don't trust atoms, they make up everything. All right, we've got two goals, two objectives for today. Number one is to solve quadratic equations by using the quadratic formula. And the second one is to use what is called a discriminant to determine the nature of the roots of quadratic equations. Now, we're going to start with an example and something that we've already learned how to solve. So we're going to solve x squared minus 10x minus 24 is equal to 0. This is a quadratic equation because the lead exponent is 2, the highest exponent. And we can solve this by factoring. Now remember, to factor, what we do is we take the value for a and the value for c, which in this case is 1, and negative 24. We multiply them, which is negative 24. And what we're trying to figure out is what multiplies to negative 24, but adds up to b, and the b value is negative 10. So the process when you're factoring is what multiplies to AC and what adds up to B when we're factoring trinomials. Now, for the number 24, 1 times 24, these are factor pairs, 2 times 12, 3 times 8, 4 times 6. Now, you have to be careful because it's tempting to use 4 and 6 because 4 plus 6 adds up to 10. The problem is, to add up to negative 10, it would have to be negative and negative. But a negative times a negative has to be a positive. And in this case, we need to multiply to negative 24. So it's not 4 and 6. In this case, we will use 2 and 12. And we'll make the 12 negative because 2 times negative 12 is negative 24. Check. And then 2 plus negative 12 is negative 10. Now, because the lead coefficient is a 1, once we have our pair, we can write the factors x plus 2 times x minus 12, because x times x is x squared, x times negative 12 is negative 12x, plus 2x, that gives us the negative 10x, and then 2 times negative 12 is our constant, negative 24, and it's equal to 0. Now, when we have a factor times a factor equal to 0, what we know is that either the first factor is 0 or the second factor is 0. And then we solve, we go minus 2. On both sides, we get x equals negative 2. And we go here plus 12 to solve. We get x is 12. And so we have two solutions, negative 2, comma 12. And you can always check. You could take negative 2, substitute it for the x's, and see if the left side makes 0, and then do the same thing with 12, and it is going to work. Now, there's a second method, and it is called the quadratic formula. And the quadratic formula is this big formula here. X equals the opposite of b plus or minus. So we read that as plus or minus the opposite of b plus or minus the square root of b squared minus 4 times a times c, all of that divided by 2a. It's called the quadratic formula. Now you can only use this for a quadratic equation in the form ax squared plus bx plus c equals 0. It has to be equal to 0. Just like factoring, we have to set equal to 0. Now you see all these letters, all these variables, and it's kind of intimidating, but the a is this number in front of x squared, the b values are here, and then this is the constant c. So let's say we wanted to solve the same equation, except this time instead of factoring it, let's solve it by using the quadratic formula. Well, we know that a is 1. Now we know that b is negative 10. That sign in front of the value, you have to include it. That's negative 10. The constant is negative 24. So here's how we set it up. We're going to write down x equals the opposite of b. Now the b value is negative 10 plus or minus. We write them on top of each other, one over the other, and then it's a big square root, b squared. Well, b is negative 10. So I'm going to put negative 10 in parentheses, square it, minus 4 times a, which is 1, times c, which is negative 24. All of this is divided by 2 times a. Okay, if I put my numbers in a different color here, every time I substitute numbers, you notice that I'm putting parentheses down here. And it's this whole thing divided by 2 times a. It's not just the square root, it's also this. Okay, now I know that, again, that looks kind of intimidating, that's very long, but this is all numbers. So all we're going to do is simplify this now. The opposite of negative 10, we're going to say x equals, well, it's positive 10, plus or minus, square root. When you square a negative, we always get a positive. Negative 10 times negative 10 is 100. Now, this is negative 4 times 1 times negative 24. If I do this with a calculator, I can multiply all three numbers at the same time. Negative 4 times 1 times negative 24 should give us a positive value because it's a negative times a negative, and we get 96. So that's 100, that's plus 96, all divided by 2 times 1, which is 2. All right, now look at how much shorter this is from the original expression. So let's keep simplifying. X equals 10 plus minus square root. If you add these, they're both under the square root. We can add them. That's 196, all divided by 2. All right, now the square root of 196 is 14. Okay, so now since that's a perfect square, we get 10 plus or minus 14, all divided by 2. And now at this point, we're ready to combine here. Now here's the thing. Plus or minus means we have two solutions. One answer is 10 plus 14 divided by 2, comma, the other answer is 10 minus 14 divided by 2. So we use the plus or minus so that we don't have to write all of this twice. We write plus minus, and then when we get to here is where we finally use it. It's 10 plus 14 over 2, and then 10 minus 14 over 2. So now we'll simplify two expressions. This is 24 divided by 2. This is negative 4 divided by 2. 24 divided by 2 is 12. Negative 4 divided by 2 is negative 2. And notice that that was the same answer that we got in the first problem. So we get the same solution, negative 2 comma 12, but we did it with a different method. And that is called the quadratic formula. Now, if you have a choice of factoring or quadratic formula, I'm always going to choose factoring. I think it's easier and I think it's shorter. But the benefit to the quadratic formula is that it always works. Not every quadratic can be factored. And if it can't be factored, well, this can be used instead. So let's practice this though. You'll find this is actually pretty easy once you practice this a few times. Go through the process. So solve the following by using the quadratic formula. Let's do 4x squared minus 12x plus 9 is equal to 0. So we're going to label A, B, C. And for this one, I'm going to write down the equation again. X equals the opposite of B plus or minus the square root of B squared minus 4AC, all divided by 2 times A. So here we go. X equals, and actually, if you're trying to memorize this, you can sing it to the children's tune, Pop Goes the Weasel. Goes, X equals opposite B plus or minus square root B squared minus 4AC, all over 2A. Kind of a cool way to memorize it. x equals the opposite of b is negative 12, plus or minus the square root, b squared, so I'm going to square a negative, minus 4 times a, which is 4, times c, which is positive 9, all divided by 2 times a, which is 4. So now we simplify. X equals, that's 12, opposite of a negative is positive, plus or minus the square root. This is 144, and negative 4 times 9 is minus 144, all over 2 times 4, which is 8. Now I can subtract these. They're both under the square root. When we subtract that, we get 0. So x equals 12 plus minus the square root of 0 divided by 8. Now this is nice. The square root of 0 is 0. So 12 plus or minus 0 over 8. And now this is kind of interesting because what happens is if I go ahead and break this now into my two expressions, we get 12 plus 0 over 8, and we get 12 minus 0 over 8, the plus or minus. 12 divided by 8 is 3/2. But this is also 12 divided by 8 because subtracting 0 is still 0. So we get the same answer twice. When we write the solution, we don't write it twice. We only write it one time. So x is equal to 3 over 2. You could also say 1.5 as a decimal. Now, what's happening, we only get one solution. This is actually kind of rare. Normally, with a quadratic, we're going to get two answers. But if I were to graph this, we're going to make a connection here. So if I take 4x squared minus 12x plus 9, that's the original equation, zoom standard. And what happens here, I'll zoom in a little bit. Notice that the parabola, it comes down, but it doesn't hit the x-axis twice. It doesn't go down and then come back through. It hits and it bounces off. Now, we talked about in the first section that a solution is where you touch the x-axis. That's an x-intercept right there. And so what happens here is that since we only touch in one place, we only have one solution. So 3 over 2 is the only answer. All right, let's take number 4. A is 1, B is positive 4, C is positive 2. X equals opposite B plus or minus square root B squared minus 4AC all over 2A. Okay? And I know I'm kind of going through this quickly. Feel free to pause and work it out yourself. Actually, that would be good. 16, negative 4 times 1 times 2 is negative 8, minus 8, all over 2. X equals negative 4 plus minus the square root of 8 divided by 2. And now we have a situation. And the situation is that 8 is not a perfect square. And so we've got a couple options. If you use the calculator, you can certainly do negative 4 plus the square root of 8 and then divide that by 2. And you're going to end up with this decimal. This is an irrational number. A non-perfect square is going to be irrational. Okay, so I could do that and then I could round my answer. But what I'm going to do is I'm going to simplify the square root of 8. So if I do a little factor tree here, 2 and 4, and then 4 is 2 times 2, and we've got the square root of 2 times 2 times 2, that's still 8. I pull out a pair of numbers that are the same, and we get 2 square root 2. So what we have here is x equals negative 4 plus minus 2 square root 2 divided by 2. Now, at this point, I can break it up, but what I'm going to do, I can reduce, if I can take the outside numbers and each of them is divisible by the same thing. In this case, they're all divided by 2, so I get x equals negative 2 plus minus 1 square root 2 over 1. And the way that we write this, we say negative 2 plus or minus the square root of 2. You can actually leave it like that. Now, I mean, that's the same thing. That's negative 2 plus square root 2, comma, negative 2 minus square root 2. This is called simplified radical form. You can leave it as a radical, and the reason why you might do that is because this is exact, but if I find decimal values, so 1 decimal is negative 0.58, so on and so on, and if I had done negative, so if I do negative 2 plus square root 2, there's that answer. If I do negative 2 minus square root of 2, I would get negative 3.4. So it's not wrong to write the decimals, but I like to leave it in simplified radical form. So you could also say the answer negative, I'll round it to the hundredths, negative 0.59, negative 3.41. And that is the end of part 1.